everyone, welcome to the Prime Education. In the last video, we have seen chapter number 1, textual exercise. So in this video, we are starting with our new chapter, chapter number 2. Is matter around us pure? So these are the contents which are included in this chapter's presentation. Definitions. Number 1, solution. A solution is a homogeneous mixture of two or more components. Number 2, alloys. Alloys are homogeneous mixture of metal and cannot be separated into their components by physical method. Number 3, solvent. The component of a solution that dissolves the other component in it are called solvents. Solute. The component of solution that is dissolved in the solvent is called solute. Tincture of iodine. A solution of iodine in alcohol is known as tincture of iodine. It has the iodine as solute and alcohol as a solvent. Solubility. The amount of solute in the saturated solution at a given temperature is called solubility. Unsaturated solution. If the amount of solute contained in a solution is less than the saturation level, it is called unsaturated solution. Element. Element is the basic form of matter that cannot be broken down into simpler substance by chemical reaction. Compound. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Answer the following questions. Question number 1. What is meant by a substance, or what is meant by a pure substance? So the answer for that is, if all the constituent particles are of same type, then the matter is termed as pure substance. Question number 2. To make a saturated solution of 36 gram of sodium chloride is dissolved in 100 gram of water at 293 K. Find the concentration of this temperature. So the mass of sodium chloride is 36 and the mass of water is 100. Here sodium chloride NaCl is solute and water H2O is solvent. So the total mass will be 100 plus 36 is equal to 136 grams. So the concentration of solution is 36 by 136 into 100. Therefore, concentration of solution is 26.47%. Question number 3. How will you separate a mixture of containing kerosene and petrol? Difference in their boiling points is the more than 25 degrees Celsius. Which are miscible with each other? Following is the process of distillation. Note, in place of acetone there will be kerosene and in place of water there will be petrol. Here there is a printing mistake. There will be petrol in place of water. So number 1, take mixture of kerosene and petrol in distillation flask. Fix a thermometer on it. Arrange the apparatus as shown in above figure. Heat the mixture slowly. So the observation we get is petrol vaporizes first as it has lower boiling point. It condenses in the condenser and collected. Kerosene is left behind in the distillation flask. Question number 4. Name the techniques to separate butter from curd. So the answer is centrifugation, salt from seawater. So the answer is evaporation, and camphor from salt. We get sublimation. Question number 7. What type of mixtures are separated by the techniques of crystallization? Answer. Pure solids are separated from impurities by the technique of crystallization. Salt can be separated from seawater as well as copper sulfate can be separated from its solution. Question number 8. Write the steps you would use for making tea. Use the word solution solvent dissolves insoluble filtrated residue. So here are the steps. Take a cup of water in a container. Here water is the solvent. Add a teaspoon of sugar in it as solute. Keep the solution until the whole sugar dissolved. Add required amount of tea powder which is insoluble in water. Boil the content and add milk which is soluble in water. Filter the tea with a strainer. The tea collected in the cup is filtrate, and which is left behind in the strainer is residue. Question number 9. Pragat tested the solubility of 3 different substances at different temperature and collected data as given below. Results are given in the following table as grams of the substance dissolved in 100 grams of water to form a saturated solution. What is the mass of potassium nitrate would be needed to produce saturated solution of potassium nitrate in 50 grams of water at 313 K? So the answer for that is 62 gram KNO3 is dissolved. Pragya makes saturated solution of potassium chloride in water at 353 K and leaves the solution to cool at room temperature. What would she observe as solution cool? Pragya makes saturated solution of potassium chloride in water at 353 K. Find the solubility of each salt at 293 K. Which salt has the highest solubility? So the answer for this is solubility decreases when potassium chloride solution is cooled. Therefore, precipitate out of the solution is formed. What is the effect of change of temperature in the solubility of salt? So the answer is ammonium chloride has highest all solubility at 293 K which means 37 grams. Question number 10. Explain the following terms by giving examples. Number 1, saturated solution. Solution in which no more solute can be dissolved at a particular temperature is known as saturated solution. For example, we can say in aqueous solution of sugar, no more sugar can be dissolved at room temperature. Pure substances. A substance consisting of single particle is called the pure substance. For example, water, sugar and salt, all these are pure substance. Colloid. Colloid is a heterogeneous mixture whose particles are not as small as solution, but they are so small that cannot be seen by naked eyes. When a beam of light passes through a colloid, then the path of light becomes visible. For example, aerosol, emulsion, gel. Suspension. A suspension is a heterogeneous mixture in which solids are dispersed in liquids. Barium, when mixed with water, the particles of barium sulfate separate in solutions. Mud and water. Question number 11. How do you confirm that the colorless liquid given to you is pure water? Take a sample of colorless liquid and put on it stir. If it starts boiling exactly at 100 degrees Celsius, then it is pure water. Any other liquid like vinegar have different boiling points. We also observe that sometimes later the whole liquid will be converted into vapor without having any residue. Question number 1. These are some extra questions given by the Prime Education. What is concentration of solution? Write different ways to express concentration. Answer. The concentration of a solution is the amount of solute present in a given amount of solution or the amount of solute dissolved in a given mass or volume of solvent. Concentration of solution, amount of solute divided by solution. There are various ways of expressing the concentration of solution. Some of these are A. Mass by mass percentage of solution, in which we are taking mass in consideration. B. Mass by volume. So we have to take mass of solute whereas volume of solution and multiply it by 100. Question number 2. Mention the properties of solutions. So here are they. Solute is a homogeneous mixture. The particles of solution are smaller than 1 nm in diameter, so they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution, so the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle when left undisturbed. That is, a solution is unstable. Question number 3. Mention the properties of suspension. So here are they. Suspension is a heterogeneous mixture. The particles of suspension can be seen by naked eyes. Particles of suspension get a beam light passing through it and make its path visible. They can be separated from the mixture by the process of filtration. The solute particles settle down when suspension is left undisturbed. That is, suspension is unstable. Mention the properties of colloid, or the question can be as mention the property of solution which show the Tyndall effect. So the answer for these are as follows. Colloid is a heterogeneous mixture. There is a printing mistake. The size of particles of colloid is too small to be individually seen by naked eyes. They are big enough to scatter a beam of light passing through it and makes its path visible. They cannot be separated from mixture by the process of filtration, and they do not settle when left undisturbed. What is Tyndall effect? When a beam of light is allowed to pass through a colloidal solution, it gets scattered. This scattering of beam of light is called Tyndall effect. The beam of light gets scattered to the small size of colloidal particles. Tyndall effect can be also observed when a fine beam of light enters a room through a small hole. This happens due to scattering of light by the particles of dust and smoke in air. Tyndall effect can be also observed when sunlight passes through the canopy of dense forest. In forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. Question number 6. What are components of colloids? Classify it. So here is the classification given in the textbook. So the components of colloidal solution are the dispersed phase and the dispersed medium. The solute-like component or dispersed particles in a colloidal form is a dispersed phase. The component in which dispersed phase is suspended is called dispersing medium. Colloids are classified according to the state of dispersing medium and dispersed phase. Question number 7. Explain the process to obtain dye from blue or black ink. Again, the diagram is given in the textbook like this. Ink is a mixture of dye in water which can separate the whole component from its non-volatile solute by the method of evaporation. So following this is the process. Fill half a beaker with water. Put a watch glass on the mouth of beaker. Put a few drops of ink in the watch glass. Now start heating the beaker. We will see the evaporation is taking place in the watch glass. Question number 8. Explain the process to separate cream from milk, or the role of centrifugation. Cream is separated from milk by the process of centrifugation. Sometimes the solid particles in a liquid are very small that they pass through filter paper. For such particles of filtration technique cannot be used for separation. Mixtures are separated by centrifugation. The principle is that the density particles are forced to the bottom and the lighter particles stay on the top when they are spun rapidly. Following are the application of centrifugation used in diagnostic laboratories for blood and urine tests, used in dairies and home to separate butter from cream, and used in washing machine. Question number 9. Explain the process to separate two immiscible liquids, or explain the process to separate kerosene and water. Answer. The principle is that immiscible liquids separate out in layers. So this is the process. Question number 10. Explain the process to separate a mixture from salt and ammonium chloride. To separate the mixture that contains a sublimable volatile component from a non-sublimable impurity, the sublimation process is used. Ammonium chloride is a volatile substance and undergoes sublimation on heating. The mixture is kept in china dish and inverted funnel is kept on it. The mixture is heated slowly and heating vapors of ammonium chloride rise to the top of funnel and get solidified at corners. Explain the process of chromatography in brief. Chromatography is the technique used for separation of those solutes that dissolves in the same solvent. Chroma in Greek means color. This technique was first used to separate colors, so this name was given. This technique is used to separate different colors of a dye. A dye is mixture of two or more colors. So following is the process. This is the diagram. And this is the process. This is the observation that the ink that we use as a water as a solvent and the dye is soluble in it. As the water rises on the filter paper, it takes along with the dye particles. The colored component that is more soluble in water rises faster. Applications is given, and question number 12. Write a note on elements. Element is a basic form of matter that cannot be broken down into simpler substance by the method of filtration. Elements can normally be divided into metals and non-metals. Non-metals usually show some or all of these properties. So they display variety of colors, they are poor conductor of heat and electricity, they are not lustrous, sonorous or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Some elements have intermediate properties between those of metal and non-metal. They are called metalloids. For example, boron, silicon, germanium. Short points given by the primary education. A solution of water in water is solid in liquid solution. Solution of iodine in alcohol is known as tincture of iodine. Concentrated drinks like soda and water, etc. Gas in liquid solution, carbon dioxide and water. Air is a mixture of gases in which gas is homogeneous mixture of number of gases. It is to the main constituents are oxygen and nitrogen. Heterogeneous mixture are that which can be separated into the respective constituent by simple physical method like hand picking, sieving and filtration. Some examples of solids are solids with sublime are ammonium chloride, temponethylene and athericine. Robert Boyle was the first scientist to use the term element in 1661. Antoine Laurent Lavoisier, French chemist, was the first to establish an experiment are used for the definition of an element. So these are the differences: homogeneous and heterogeneous, solid, solution and suspension, mixture and compound, elements and compound, physical change and chemical change. So that's it for today. In the next video, we will start chapter number 3's textual exercise. Please like and subscribe to our channel.